Hi folks, welcome to this next CaGIS interview. So we've heard a lot about GIS systems and performing geographical operations with natural language input. So you can type in a phrase and a GIS will respond with some sort of map or analysis. However, most of these use large language models. So these are cloud-based systems, so your data is transferred out of your computer to a central system, and you often have quite high operational costs for these. Today I'm joined by Mahdi Nazari Ashani from the Department of Geospatial Information Systems, Faculty of Geology and Geomatics Engineering, all part of KN2C University of Technology, Tehran, Iran. He and his colleagues, they've developed an autonomous web-based GIS, but that does this task using a small language model. So operates entirely in your browser. So Mahdi, it's great to have you here. Um, Please, can you tell us a little bit about AWebGIS and your approach with this?
Well, I'd like to introduce about the AWebGIS right now. AWebGIS, or Autonomous Web-Based Geographic Information System, is a platform that allows users to perform GIS operations using natural language instead of traditional methods, tools, or programming. A user can simply type instructions such as zoom to uh, the selected layer, calculate the buffer around the feature, or change the layer color to red. And the system automatically translates those requests into executable JS functions. Our research focused on creating a browser-based version of AWebGIS that can operate autonomously while reducing dependence on cloud infrastructure, making geospatial analysis more accessible, intuitive, and privacy friendly, mostly.
Cool, great stuff. So yeah, those are a couple of the big key advantages of using the small language model, the SLM, rather than a more traditional large language model. Could you expand a bit more on that, on some of the benefits of the small language model?
Yeah. Traditional large language models or LLMs are powerful, but typically require cloud-based infrastructures, which means user data must be sent to the remote server, and inference costs increase with usage. In contrast, our small language models or SLMs are fine-tuned, specifically for GIS function prediction and run entirely inside the user's web browser. This approach eliminates token-based costs, reduce latency, and removes the needs for large-scale server infrastructures. Interestingly, for this specialized GIS task, our best SLM actually achieved a higher exact match accuracy than the cloud-based LLM. We evaluated demonstrating that carefully trained small models can be highly effective for domain-specific applications.
Cool. Excellent. So it's an amazing feat of engineering that we've got here. Can you say a little bit more about what your current implementation can do and what it can't do? So both in terms of the kind of understanding user queries, but also in terms of the GIS operations themselves.
Okay. The SLM can perform a wide range of common JS operations, including map navigation, layer management, spatial analysis, and cartographic sliding. For example, it can zoom to location, load WMS and WFS layers, that map service, and web feature service, as you know, OGC services. Add or remove data sets, calculate buffers, centuries, lanes, and areas, and modify the map appearance such as colors, labels, and symbols as its cartography. However, the model is currently limited to a set of JS functions. Uh, it was trained. It was trained on. It was trained on It is not yet designed for highly complex geospatial reasoning, advanced multi-step workflows, sophisticated spatiotemporal analysis, or open-ended conversations. I believe that future works aims to expand these capabilities and support more advanced GIS tasks.
Wonderful, thank you. And if people want to experiment it and run it themselves, how can they do that? What are the steps they need to do?
Great. One of the key advantages of our approach is its simplicity. The system runs directly in a modern web browser using WebAssembly and WebGPU technologies. So users don't need a specialized hardware or cloud services to run the application. The application can load our fine-tuned models from local storage or from online repositories such as Hawking Face, and all inference take place on the user's device. We have also made the code and related materials publicly available on GitHub, and you can find it also on the papers page, allowing researchers and developers to reproduce, modify, and extend the platform for their own application. Also, we have provided another video that you can check it out for running the application on your own device.
Cool. Yeah, and we'll include the links below in the video, so do check out those links. And finally, what are the next steps for your research? How would you develop this going forwards?
Okay, that would be great if we can follow the next steps. Our next goal is to expand the range of GIS operations that system can understand and execute, moving beyond single function commands toward more complex workflows and autonomous spatial analysis. We also plan to investigate newer small language models, alternative fine-tuning methods such as LoRa and QLoRa and other techniques that can improve efficiency while maintaining accuracy. Another important direction in adding memory and retrieval capabilities, so the system can maintain conversational context, answer follow-up questions, and provide more intelligent assistant while still preserving benefits of on-device execution.
Cool, great. No, that sounds really good. We're looking forward to seeing the developments there. And lastly, I understand you're looking for a PhD program to participate in. Is that correct?
Yeah, I've studied my Master of Science in Geospatial Information Science, and I prepared myself for the next steps. My goal is to find an appropriate PhD program to study and continue my future academic career.
Great. So if anyone watching knows of any good PhD programs or you want Mahdi for your program, please do reach out to him and get in touch. Awesome. Well, Mahdi,
Thank you
it's
very
great to have you here on the program, and thanks a lot for sharing all of this. We've also got a video recording of the tool in use, so I'll link to that below as well. So please do check out Mahdi Nazari's paper, and any comments, please let us know, and please subscribe. Thanks very much, everyone.